Hello. So here is a nice problem on group theory. The question is, does there exist a non-trivial homomorphism from Q by Z to R star? So the answer is no. So to prove this, we'll use various concepts of group theory, namely the first isomorphism theorem. So let's see the solution. So before that, let me make some recall. My first recall is Q by Z has all finite ordered elements. I mean, any element of Q by Z has order finite. So therefore, the image of any element of Q by Z under F is also finite in R star. Now, now the question is, what are the only finite subgroup of R star? Answer is either it is identity element, the trivial subgroup, or minus 1 comma 1, that is the Z2 type of subgroup in R star. So now by using the first isomorphism theorem, you get Q by Z by kernel of F is isomorphic to minus 1 comma 1 if you consider that let's say the image of F is minus 1 comma 1, because we have to find non-trivial homomorphism, which implies that kernel of F is a finite inner subgroup of Q by Z. Because, I mean, let's say G H is a subgroup, normal subgroup of G, and G by H is finite index. That means H is a finite inner subgroup of G. So here kernel F is a finite inner subgroup of Q by Z. But this is an exercise which I'll encourage you to solve, that Q by Z has no subgroup, no proper subgroup of finite index. That is, the only finite index subgroup of Q by Z is Q by Z itself. Hence image of F cannot be minus 1 comma 1. So the only possibility is image of F is the identity element. So the only homomorphism possible is the trivial homomorphism. So the answer is no such non-trivial homomorphism exists. Hence proved.